All right, let's jump right into this explainer. We're looking at a super counterintuitive problem in AI engineering today. We're totally hardwired to believe that more computing power, more iterations, and just having a model think longer is going to automatically give us better results. But today, we're unpacking a massive misconception. It turns out simply telling a language model to double-check its own work does not automatically improve quality. In fact, as we're going to see, under the wrong conditions, giving an AI more time to think is literally the exact thing that ruins the output.
We're going to kick this off like a bit of a detective story, dropping right into a pretty frantic Tuesday evening email. Meet Diane. She's a 22-year veteran underwriter at a $12 billion thrift called Brookhaven Mortgage. Basically, Diane is the reviewer of last resort for their really complex loan packets. Well, she fires off this email flagging that their automated document summarization tool had suddenly started generating these weirdly off, even contradictory appraisal narratives. The core numbers? Totally fine. But the text itself read like it had been heavily re-edited by someone desperately trying to find something, anything, to fix.
And this wasn't just some minor formatting glitch you could brush off. The acceptance rate on Diane's desk had literally plummeted by 8.4% over a single weekend. Now, in a high-volume underwriting environment like Brookhaven, an 8.4% drop in automated processing, that creates a massive pipeline crisis. Suddenly, you've got highly paid human reviewers having to manually reread full, dense appraisal PDFs right before closing day. If you know the mortgage world, you know that is an absolute nightmare.
Unpacking the release notes for their software's version 2.5 reveals the inciting incident here. The engineering team had added what they genuinely thought was an upgrade, a same-model self-check loop. The workflow seemed incredibly straightforward. First, the AI generator writes an appraisal summary. Then, the exact same model, using a slightly stricter rubric, is asked to review and fix its own work. Sounds completely logical, right? I mean, it's exactly how we teach humans to write. But in this architecture, it completely broke the system.
This whole phenomenon actually perfectly mirrors a canonical 2024 negative result from Huang and colleagues at Google DeepMind. They prove that intrinsic self-correction, which is where a model criticizes itself without any external ground truth signals, actually degrades performance on reasoning tasks. It's a finding that explains exactly what Diane was dealing with. The AI was basically trapped in its own echo chamber, forced to rewrite good work over and over until it just became bad work.
So let's move to the autopsy of this system. We need to outline the 4 specific conditions where adding a self-check loop actively hurts your data quality rather than helping it. Because if you skip any one of these checks in your architecture, your automated loop is going to drift right away from the truth. Let's walk through these traps.
The first, and honestly most common culprit on subjective generation tasks, like writing an appraisal narrative, is confirmation bias. See, before the version 2.5 update, Diane's acceptance rate for these AI summaries was already a stellar 91%. The first attempt was usually right. But because the self-check loop was explicitly told to review and correct, the AI basically hallucinated errors just so it had something to fix. It ended up introducing completely spurious edits that ruined a perfectly good summary.
And that brilliantly illustrates the second failure mode, the correlated verifier. If you ask the exact same model to grade itself on the exact same dimension it just optimized for, say completeness, you aren't actually verifying anything. You're just building an echo chamber. You've got the exact same blind spots at play. The model is just reinforcing its initial mistakes with higher confidence, dragging the whole output further and further away from reality.
The third trap is the lack of an early exit. Letting a loop run iteratively until a fixed cap or time budget runs out, incredibly dangerous. There's an old engineering saying, more thinking is not a free lunch, and it totally applies here. If your system doesn't dynamically check for confidence or convergence to know exactly when to stop, those forced additional iterations just introduce drift. The model over-edits the text until it completely loses its original meaning.
The fourth condition is a trap practitioners fall into all the time, using a weaker verifier. To save on compute costs, developers will often use a massive model to generate the text and then a smaller, much cheaper model to verify it. But as the 2021 Cobase study established, verifier capability matters immensely. A weak verifier doesn't give you a clean signal, it just injects noise that ruins the generator's hard work. It's quite literally like having a high school student grade a PhD thesis.
So, with all these traps laid out in front of us, the million-dollar question is, how can we safely deploy self-correction in a modern production environment without completely breaking the pipeline? Because make no mistake, self-correction can be incredibly powerful, but only if we use the right design rules.
Enter the hero of our detective story, the Orthogonal-Criterion Principle.
This principle dictates that your verifier absolutely must look at the problem from a totally different angle. It means asking a completely different question to strip away the original blind spots. For instance, if your generator was optimizing for completeness to make sure every appraisal detail was included, your verifier has to check for something orthogonal, like checking for hallucinations against a retrieved context PDF. It's a different question, which means entirely different blind spots. Now, this principle relies heavily on distinguishing the type of data we're actually processing. Self-check often hurts subjective tasks, like writing those free-form appraisal narratives, because there isn't a strict right or wrong answer, but it absolutely thrives on verifiable tasks that have a computable ground truth. Think about extracting the debt-to-income ratio. That is a hard number. The verifier can easily check the extracted number against a deterministic, mathematical recompute of monthly debt and gross income.
To really see this in action, we can look at Brookhaven's actual data. They ran a test across 3 different variants: a same model verifier, a weaker model verifier, and a stronger orthogonal verifier. And they tested these across both their subjective and verifiable document fields. What they were measuring here was the quality delta versus using no self-check at all.
The difference here is just stark. The same model and weaker model variants actually dragged performance down into the negatives for subjective fields, dropping by 0.6 and 0.8. Yikes. But look at variant C. The orthogonal verifier is the only one that actually works. It achieved a massive plus 1.1 boost in quality on verifiable fields and a modest 0.3 boost on the subjective ones. It's a total game changer.
So the really crucial takeaway from this explainer is the step-by-step resolution to Brookhaven's crisis. First, they just disabled the self-check entirely on those subjective appraisal narratives where the first-pass quality was already super high. Simple enough. Second, for the fields that did keep it, they changed the verification dimension to be orthogonal. And third, they added an early exit so the loop intelligently stopped itself as soon as the model converged.
By following these definitive deployment rules, you can make sure your automated loops are actually pulling toward ground truth, rather than drifting off into hallucination. Look, if you're building agentic workflows, you have to be willing to make the tough, negative recommendations. Tell your team to actually turn a feature off when it comes to same model checks on subjective fields. And definitely stop trying to save pennies by using weak verifiers that just end up ruining your data quality.
As you go back and review your own multi-agent workflows today, I want you to ask yourself one fundamental question. Are you genuinely verifying the work from a fresh, orthogonal angle? Or have you accidentally built a system that just confidently reinforces its own blind spots? The answer to that question is literally the difference between a broken pipeline and true production-ready AI.